in the Science Center, we have an exhibit called Chaotic Pendulum. And it's as it sounds, it is a pendulum, and its movements are chaotic. Once again, expensive materials, magnets, a pencil with a straight pen through the eraser, a piece of string tied in a loop, and some Scotch tape. I'm often asked, where do you get your magnets? Well, you can order them from a scientific catalog if you want, but better still, these are called cabinet magnets. And as you can imagine, cabinet magnets are used in kitchen cabinets. They put a screw through this hole here, screw it to the wood, put a piece of metal on the door, and this becomes the latch that holds the door closed. And I guarantee if you go to a cabinet maker in your hometown and tell them what you're doing, that they'll probably give you, a half a dozen of these magnets. They're very inexpensive, so I'm sure they'd give it to you. And we start this by laying a magnet on the table and taping it down. Now, it doesn't matter about the polarity of the magnet. All we're going to do is establish, because the beginning one, what we want to do is we want to establish the same polarity on all the magnets. So I bring my first magnet close to it, and it's attracted. That tells me that the polarity is unlike. I want like polarity, so I turn the magnet over, bring it down. It's now repelling. I take that side and I point it up. Now, both of these magnets have the same pole up. Tape it to the table. And I do the same with the next magnet. And that one's already at the right polarity, so I'll put that polarity up. And I take the last magnet and I test it for the same polarity. Well, turn it over. This is the same polarity. Now I want to make sure I keep that polarity the same. Take a piece of tape. Make sure I keep that polarity. This polarity up and this polarity down are the same polarity. Tape it to my pendulum. It's not a pendulum yet, but when I wrap the string around the straight pin, it's now a pendulum. Ask the students to make a hypothesis. What's going to happen when I pull this pendulum back and release it? What's going to happen? Well, it's going to swing straight back and forth. Bring it close to your magnets and watch what happens. There is no straight back and forward swing the way we would expect it. Completely counterintuitive. If you want to add even another little surprise to it, cover this up and then set up the situation and ask the students to use some critical thinking skills. What's causing this pendulum not to swing straight back and forth? Involve them. Why do you think that could happen? What could possibly cause the pendulum not to swing straight back and forth? Another way you may be able to use this is in the math principle of chaos. Chaos is a relatively new area in science, and it deals with the idea that things aren't as patterned as we think they are. There's a lot of chaos in the universe. And if you set yourself up in the same position every time and swing the pendulum every time, it will be a little different each swing. So there's a very effective way to demonstrate chaos.